third week of the Mid-Dale Amateur Radio Club Technician class. I am Leah, W3LEO, which I know a few of you in the chat have talked to me via email, so now you got a face with the name. Thank you all for coming tonight. And again, we are having an interactive chat, so if you have any questions during the time that we are of any subject that we're speaking about, feel free to get in the chat and we will answer the questions. Of course, tonight we're going over the last 6 chapters in the book, which is Multimode Radio Excitement, Electrons Go with the Flow, which W5DRO, my helpmate, he prepared several videos for us, so we'll be able to watch a little bit of that when we get to that point. We're going to be doing Picture This, schematics, antennas, feed me with some good coax, and safety first. So, let's get started. Alright, the properly adjusted single sideband transmitter on the UHF and VHF frequencies for technician class operators is 3 kHz bandwidth, depending on your voice characteristics. By convention, we employ upper sideband for VHF and UHF for weak signal work. Now, real quick, those that are new to the class, if you notice any of the test number, the test numbers, like the T, like right here it says T8, A08, page 122, which the page is for the book, for Gordon West's book. Now, of course, if you're using the ARL book, you can just look up where it's at in that in the book itself. But those are the questions we'll be going over in the exams for this coming up weekend. So just remember those. Okay, that's why those are there. All right, here is our overall bandwidth carrier, which is lower sideband and upper sideband. And if Donald could speak a little bit more about that. Again, I'm still learning. I am an extra class, but I am still learning. So I'm going to now go to Donald.
Okay, so what you just saw on the slide was the carrier, which was in the center, and I'll bounce back over to the slide here in a moment. I don't have it set up for audio over on that slide when you're coming to me. However, you'll have the carrier in the center, and then you have the upper and lower sideband of the radio signal that you're transmitting when you are operating in AM. Now, AM would have all three things: the carrier and the upper and the lower sideband. If you are going to be using single sideband, be it either lower sideband or upper sideband, your signal would all be focused. Your carrier and that other sideband would all be focused onto the one sideband that you are using. So with that, you can see that single sideband is actually very good power-wise, because you're not using the power spread across the entire band. And when we had just discussed that it was 3 kilohertz wide, well, that's the single sideband is 3 kilohertz wide. If you're talking in AM, it's going to be 6 kilohertz wide, or even wider if you set your radio to it. So I'm going to pop the slide back up, and Leah can narrate a little bit more about it.
All right, again, you see the overall bandwidth is twice of that top modulating frequency, like you said in the slide, the lower sideband and the upper sideband, which again, that's some of that stuff's like, woo, big stuff, but it's okay. We'll get there. All right. We use frequency modulation through FM repeaters on many popular VHF and UHF ham bands. But near the bottom of the 6 meters, 2 meters, and 1.25 meters, and at 432 and 1296 megahertz, we use single sideband, which uses less bandwidth than FM signals. So those are on the single sidebands. The properly adjusted single sideband transmitter on VHF and UHF frequencies for technician class operators approximately is 2 to 3 kilohertz of bandwidth, depending on your voice characteristics. We employ did I just say this? It sounds like I repeated myself, but okay, I apologize if I do. We employ upper sideband for VHF and UHF for weak signal. I don't know where that came from. Okay, here we go. Something new. All right, if you plan to do some weak signal work, great. We need more signal weak operators, which is CW, or Morse code. and single sideband. You should set your receiver RLT with the retreat or the clarifier to a neutral position. Then you adjust slightly for the big knob for the proper single sideband reception. You can then make fine-tuning adjustments with the receiver, RIT, or clarifier. Now on myself, of course now you probably know that you don't have to know Morse code to take the technician test. So, but it is a great thing to learn on the side if that's something that you want to learn. I myself can't hear it. I can't differentiate the dits and the dots. It makes me sad, but that's just how it is sometimes. But anyways, we'll keep moving on. Alright, the mixer is a non-linear device that takes two radio signals and creates both the sum and the difference frequencies of the two input frequencies. A simple diode can act as a mixer, but most modern-day radios have a much more elegant arrangement using several diodes or active devices such as transmission or FETs, F-E-T-S, to create a mixer circuit. Now, if there's any questions on any of this stuff, I'll give it to Dom because obviously I'm just still learning this stuff. AGC, which is automatic gain control, formerly known as AVC, or automatic volume control, is used to somewhat level up the huge variations in signal strength that a signal can undergo between a distant station and your receiver. We use a slow AGC for voice reception as fast AGC for CW. CW is Morse code. Now, as a new technician, you want to explore that's all available to you. The weak single sideband, or CW operation, is permitted in at least some portions of the amateur bands above 50 megahertz. Now, side note, once you pass your test, which you will, everyone will get a band plan, so you'll be able to know where you are allowed to go once you're ready to get on the air. Now, you can try some CW down the worldwide portions of your technician class privileges on 80, 40, 15, and 10 meters. When you switch your multi-mode rig over to CW, you will see that the bandwidth narrows down. This minimizes the pickup of other CW signals off frequency. 150 hertz is just right. Now, the capability of any radio equipment to specifically hear one frequency and discriminate against signals on either side of that frequency is called selectivity. On VHF and UHF equipment, the selectivity is usually preset and most equipment is plenty selective. Alright, we're now going to go to Donald real quick. He has something that he wants to speak about.
Yeah, Leah, your selectivity is very, very, very not good when it comes to hearing what I have to say.
Oh, he wants to get kicked, doesn't he?
What?
He wants to get kicked, doesn't he? Since he's my husband, he can get away with it to a point. Alright, your radio equipment already has an excellent built-in preamplifier. The preamp goes in between the antenna input and the receiver. Now be careful how you wire it you simply put it on the outside of the equipment. The first time you transmit, the preamp is history. Alright, Q signals. This is the world of amateur radio. These are the words that we say when you are on the air. So one of the most popular ones is, let me find it, well, it's QSL. I'm acknowledging receipt, QSL. QTS, I will send my frequency, so you do that. QTH, my home. Some of these we still haven't really used, but these are some of the quick ones. We do say like CQ, well those are Q signals, not CQ, never mind. Alright, so that's what some of the Q signals, it's just this length, it's just to shorten down what you are trying to say, so you're not having to say the whole, what you're saying, if that makes sense, okay? I thought. Alright, is there any questions for the last section? I know it is
No.
crash course, it's short and sweet, so. Alright, so but
No, there's no questions. Sorry.
okay, well that means we're doing good. Alright, Now we're going to run some interference protection. Some base station radios for high frequency 10 meter work and for weak signal VHF and UHF operation have a microphone gain control. Set the control about half scale. Turning the control wide open will set the mic gain too high and will cause transmitted signals to become distorted. Oh, distorted. What did I say? Distorted. You don't want to.
You said sorted.
Sorry, distorted. And that is a question on one of the exams. Some base station radios are for weak signal VHF and UHF operation have microphone gain control. You should always set the control about half scale. Oh, did I just said that? How come I just repeated the same thing? I apologize. Okay, having your microphone gain set too high, which there are some you're going to have, because they touch up on some of the same stuff in multiple questions. So it might seem like it repeats, but that's how you remember stuff. So, having your microphone gain set too high will cause excessive deviation and it is the primary cause of an FM transmitter using too much spectrum space. If someone tells you that you're over-deviating, like you're overpowering or you're echoing back of yourself, simply back off the microphone an inch or two, which will reduce the modulation. Is something wrong? Okay. Alright, here's a fun one. So if you have a radio in your vehicle, like a mobile radio, if your automobile has a hefty alternator charging system without filters on the leads, the AC from the alternator will put a high-pitched whine on your transmit and receive a signal. It will sound like a singing noise that changes when you accelerate or let off the gas. And we're going to go to Donald real quick.
Right. I want to touch on this point real quick because the truck that Leah is currently driving has that problem. And we made a filter. I took it and found a capacitor, which we'll talk about here in a little bit, a capacitor, and I made an inductor to filter out that noise. And I put that on the input side of the power, and it completely took away all the noise. Now, it's been in service for over 10 years now, because I've been ham over 10 years now, and it is now, I think the capacitor has kind of seen the end of its life, so I'm going to be replacing that soon. And what I'll do is I'll make that a project, and I will post it on the YouTube channel as soon as I get done with it. Back to you, Leah.
Thank you, Donald. Appreciate that. All right. If in any interference case you want to make sure you have a clean house to start with, assuming you are transmitting a clean signal, this situation indicates cable leakage, which can result from anyone possibly dozens of improperly installed cable connectors, mainly and also in a cable TV installation. So if you have cable at home, then you know what it means when you have the noise and have the distortion in your signal because it's not clean. Alright, on the UHF and VHF handbands, no filter should ever be added to your antenna system. But if you decide to add a low-pass filter on the antenna connection of your radio, it goes between the transmitter and the antenna. Your radio should already have a low-pass filter installed to remove the harmonics, the noises. Now, while listening to your local repeater, your handheld picks up nothing but hash noise. Your buddy is using a mobile radio and amplifier that needs some tweaking. It is causing the transmitter to overload your receiver with harmonics and spurious emissions, which that is another subject Donald has touched on a lot in our club as well. We can talk more about that another day, but that is something that you can have in your handheld radios. And but anyways, and all of this leads to free radio frequency interference. So don't buy questionable used gear or buy cheap radios. Honestly, you will want to be very mindful of what you buy, because there are some things out there that will create spurious emissions and you will cause interference to someone else. Don wants to talk over this.
Thank you, Leah. So there is a problem with very cheaply made radios, and what they can cause problems on the handbands, and I will go through it more in depth. But remember this: you get what you pay for. I mean, your mother probably taught you that back when you were a kid. You get what you pay for. So if you pay dirt cheap for your radio, you get a dirt cheap radio, and that is not always good, because if you can't, you may have heard your mother say, if you can't play in the yard, stay in the yard, you can't play outside at all. Well, the FCC could say, well, if you can't stay in your bands, then you can't get on the air at all. So back to you, Leah.
Thank you, Donald. And if you have anyone have any questions about radios or brands in the chat, or even when we do our testing session next week, this coming up weekend, feel free to ask. I mean, yes, we do have preferences, like those that prefer Chevy over Ford and Dodge, etc. We're the same way with amateur radio equipment. We each have a preference, and Don wants to go back again.
Sorry. Well, I just wanted to say, Leah, OK Droner, which I think is Winfrey, he said that he had the problem with his motorcycle with the audio whine from the alternator. So maybe Winfrey, if you want to share like any pictures or something like that, we would love to have those. So send any pictures of your filter to Leah. I think that would be kind of cool to include in like a newsletter or something.
Yes, I could use more stuff for the newsletter too. I would be more than happy with that. Thank you, Donald and Matt. All right. All electrical conductors are capable of both radiating and receiving radio frequency energy. This is great in the case of an antenna. It's not so great in other applications. So when you don't want a conductor to radiate or to receive radio signals or other interference, the use of shielding is often an effective solution. The most familiar shielding wire is a coaxial cable, which we will be touching more into that after a bit. Okay. It is unlikely the UHF and VHF signals will cause television interference to your neighbors on an outside antenna or on the dish or on cable. To help prevent it, first double check that your equipment is well grounded and operating properly, and double check that your TV is working okay when you're transmitting over the air. Now, there is some cases when you can get on the air that might cause some fun interference. We have those little touch lamps that you have in our bedroom. When we get on UHF or VHF, when we get on the high frequency bands, it will cause them to go on and off on their own. Sometimes the one by Donald's side goes on and mine doesn't, or mine will go on, or vice versa. So I could be laying there and the lights will be going on and off, and I know he's on the radio. So sometimes it affects touch lamps. Alright, Part 15 devices are unlicensed devices that use low-power radio signals. They are prohibited from causing interference to other licensed devices, such as amateur radio. It must accept any interference from a duly licensed transmitters, amateur or otherwise. It is rare to happen, but you need to know that they are out there. Unfortunately, a lot of consumer equipment is designed and built as if they were the only occupants of the radio spectrum. No matter how pristine and clean your amateur radio signal is, some types of interference, such as front-end overload, can be fixed by applying filters to the consumer gear. Did you want to say something, Dawn? Okay, go ahead and go to Dawn. Don't go yourself.
Thank you. Oh, I just take myself. Part 15, yes. Any equipment that is labeled as Part 15 equipment must accept any interference from a licensed signal. That doesn't mean we have the right to be buttholes about it. Sorry to say that. So if your neighbor does complain that you are causing interference, the best thing to do is to be neighborly and help them with that. Help them fix that interference. Back to you, Leah.
Thank you. Now, a band reject filter removes, or at least greatly reduces, a specific range on radio frequencies. To prevent overloading of a sensitive VHF receiver front end by a local high-power FM broadcast station, it is often useful to reject the entire FM broadcast band by means of a band reject filter. Under overload conditions, a wideband RF preamplifier is the last thing you want, as it will generally exasperate the problem. And that is a question on the exam. Alright, now we're going to get into this fun. Electrons, go with the flow. Now there are going to be some parts we're going to be talking about that I don't have the test questions on there, but they're like very small in the actual book, so I think you'll be able to get it just fine. But another name for voltage is electromotive force, and as we say, may the force be with you. After all, may the fourth will be here soon. Alright, electromotive force basic unit of measurement is the volt, which I know you all have know about the volt. The flow of electrons in a conductor is called current. Current is measured in amperes, which is also known as amps. The battery. Sometimes we use batteries to help, whether it's at home or when we want to do outside, like your own little station. Like if you want to go to the park, you have to have a way of powering up your radio. But we use batteries too. We can't just always do solar power because they don't always get sun out, but using batteries. So we will be going over some important things about batteries, okay? Batteries generate direct current. Even though a current may vary in value, if it always flows the same direction, it is the direct current, which is DC. Now luckily you won't find any handheld batteries shipped with carbon zinc non-rechargeable batteries. Alkaline and carbon zinc batteries will only work once and should be properly disposed when depleted. Of course, when you get a radio from wherever you get one from, they're obviously rechargeable, and you don't put like little double A's in there or anything like that. It's a nice rechargeable, and they come with the base station. Now, think of voltage as water pressure in your kitchen plumbing. Open the valve, turn on the switch, and current begins to flow. The pressure is voltage, and the trickle of water could be similar to current. Now, we measure current in series with the device under test. The ammeter is placed in series with that lead. And we forgot to put a picture on there, but it's okay. It can be Googled. And we went too far. Okay. Dawn has prepared us a fun video about electrons, and I will also have some little things to show afterwards. So take a few minutes and let's get started.
Just the other day, my wife and I were sitting on the couch having some intellectual conversation when the subject of multimeters came up. She asked me, "What the heck is a multimeter?" And today we're going to be talking about multimeters. More specifically, we're going to be talking about the multimeter that I have. I have a Fluke multimeter. Fluke is a brand. It is a very good brand. I would recommend it to anybody who's looking for a multimeter. So if you are looking for one, I have a link to one in the description below. This one has a turn dial to select which mode you want to use. So you just turn this knob to select what you want to measure. Let's take a closer look at all the settings we have on here. Of course, the indicator is indicating to it off right now. The meter is off. We have volts AC, which is indicated by the wavy line above the V. Of course, the V stands for volts. We have volts DC, which shows two straight lines. One's dotted, meaning that you have polarity, positive and negative. Remember that you have positive and negative on volts DC. You have millivolts DC and AC, indicating with that yellow wavy line across the top. And of course the DC with the straight line. Then you have ohms, and above that you have a continuity check, which will beep a sound, and then you have a diode check. it'll actually show you the voltage forward drop on it. You have capacitance, amps DC and amps AC. Amps AC requires a special probe. You have milliamps AC and DC, and then you have microamps AC and DC. Now we're going to change topics and talk about resistance. Here's a funny comic showing Ohm's law in resistance. Resistors come in many shapes and sizes. Right here is just one of many packages a resistor comes in. This is a through-hole component design, and this is what many hobbyists will work with. This is a surface mount design. Sometimes they're no bigger than a grain of rice. And here is a power resistor. And right here is a light bulb. What is a light bulb? Is a resistor too. These are conductors. Conductors conduct electricity, and when you use a multimeter to check it, it shows up as almost 0 ohms, which means it's a good conductor of electricity. Now, right here is a piece of carrot, dried up piece of carrot. It's registering at 1 mega ohm. So other things can conduct electricity. And here is a resistor. This is a 1K ohm resistor being measured. Now here's what the typical resistor looks like. So how do we figure out what the value of this resistor is? Red, violet, brown, gold. Well, there is a well-known chart that tells us. It's the color code chart for resistors. And here it is. So you got the 3 different bands that we're going to take a look at. The first band was red, and red shows to be the number 2. The second band was violet, and it shows to be number 7. And the third band is brown, and that is our multiplier, and that is a 10, so a multiplier of 10. So this resistor is a 270 ohm resistor, and it has a gold band, which stands for the tolerance of 5% tolerance. Now, you could commit that to memory, or you could use a simple to use calculator that is available on most any website. Again, select the number of bands on the resistor and select the color for each band. So again, red, violet, and brown. And of course, we gotta select our tolerance of gold. And this tells us that it is a 270 ohm resistor with 5% tolerance. All right, now that we've learned all of that about resistors, there's one last thing we need to know, and that is, what does it look like on a schematic? A schematic symbol for a resistor is this. It's a straight line with squigglies and then another straight line. The straight lines are the leads of the resistor, and the resistor is represented by the squiggly lines. All right, that's all we need to know about resistors. Now let's move on. So now we're going to be discussing inductors. Now, an inductor is also called a choke or coil. It is a passive 2-terminal electrical component that stores energy in a magnetic field when electricity is flowing through it. An typical inductor consists of an insulated wire wound into a coil around a core. Now, as you can see, these are 2 air core inductors. Notice that you can see right through the center of the one that's standing on end. That means it's an air core inductor. Right here is an example of an iron core inductor. Notice that it is just like an air core inductor, except that it has an iron rod down the center of it, and there's some epoxy holding it in. Now let's move on to the schematic symbols. And right here is the air core inductor schematic diagram. This is the iron core inductor schematic diagram. Notice how there's 2 vertical lines next to the coil. That is indicating that this is an iron core. And here we have the ferrite core inductor schematic diagram. Now, what is ferrite, you may ask? Well, it's a ceramic compound consisting of a mix of oxide of iron and 1 or more other metals. Ferrite has a ferromagnetic property and is used in high-frequency electrical components such as antenna design. And lastly, we have the variable inductor core. Now, the variable inductor is indicated with the arrow that is passing through the core of the inductor. There are many variable inductors being used in radio applications today. And here you can see the basic design of a cord inductor. It has the wire that's wrapping around the actual core. Now we're going to talk about transistors. Now, transistors come in many shapes and sizes, and there's no way that I can cover them all in this short video. However, I can give you a few examples of what they may look like. Okay, laid out here is several different types of transistors. On the far left, we have like a surface mount type of transistor, and on the far right, we have like a high power transistor. Now, again, these are there's so many different types, we're not going to be able to discuss them all. However, there's switching and then there's amplification type of transistors. Now, we're going to move on to the schematic diagram now on what it may look like on a schematic. Now, here's the schematic diagram of most transistors. Now, there's a base, emitter, and collector on every transistor. Now, you may notice that there's 3 leads on the ones on the left here. And if you recall back from that picture before, there was a big high power transistor. It only had 2 leads on it. Well, the 3rd lead is the can, the actual base of the transistor. Yes, that could be part of the circuit too. On to the subject of capacitors. Here is just a few of the capacitors that I have on hand. I have a few electrolytic capacitors, some mylar capacitors, and some ceramic capacitors. Now, ceramic capacitors are most likely non-polarized, and some mylar capacitors are non-polarized. So that means you can hook them up in the circuit in any way. However, these can type of capacitors, they are polarized, and they need to be hooked up in the correct way or bad things can happen. So, as you can see, hooking these capacitors up in the reverse polarity is no joke. Do not do it. Now, there's one last capacitor we need to talk about, and that is the variable capacitor. This is a picture of a variable capacitor. As you can see, there's several different plates, and each one of those plates turn along with that knob. Now, there's some fixed plates in there also that don't move. Now, whenever you turn the knob, the spacing in between each one of the plates changes minutely, which changes the capacitance. These are used in a lot of tuning applications. All right, now we're going to be talking about transformers. Yes, transformers, like the one that you see on the telephone pole outside your house. That's a transformer. All right, but the ones that we mess with are going to be a little bit smaller in nature usually. Here is an example of all types of transformers. Now, you got big, heavy ones and smaller, lighter ones. These smaller, lighter ones can work at higher frequencies easily. The bigger ones are more of a high-powered transformer type of thing. And this is the schematic diagram of a transformer. You have a primary side, which is where the main electricity that you want to transform into another power comes in at. And then you got your secondary sides. Now, there could be 1, 2, 3 tapped positions and several different. So there are several different types of transformers that could be out there. This one shows the primary side coming in and 2 secondaries, and it looks to be like those secondaries are going to be in equal voltage. Now, we need to remember one thing, and that is transformers only work with alternating current. They do not work with direct current. Got that? Alternating current only. Thank you for watching.
Thank you, Dawn, for working hard on that and giving us those videos on showing us all the different capacitors and all that fun stuff. And now I just realized I don't know where I set my little radio that I was going to show. Oh, okay. No, my other radio. My AM radio. Oh, shoot. Okay. Sorry, guys. I know I'm talking off subject, but I just remembered something. Okay. Our next... Oh, give me just a second. Sorry about that. Okay. We're now going to our next chapter. Did anyone have any questions about what Donald just went over? Has gone over on the... about inductors and... Yeah, make sure to ask in the chat. I don't know why he has to remind me to tell me that. Sorry.
Nothing there yet.
Okay. Alright, so we're going to learn about the law. Mr. Ohm's Law. Ohm's Law. Yay, Ohm's Law. Okay, electrical energy being used is measured in power. You likely have a power meter on the side of your house, which will refer to power in watts. Ohm's Law. Here's Ohm's Law. It looks like a pie. This is how you figure out whether you should multiply or divide to figuring out the answer to what you're wanting to learn. E is volts, I is current or amps, and I is resistance, ohms. Then you have pi. P is for power, which is watts, I, current, amps, again, and E is volts. So you... Oh, Dawn, go Dawn. Sorry.
Okay, so as you were seeing there, what you could do is if you know any of the two other things, you can figure out what the other one is. So let's say you have 12 volts, and you have 2 ohms of resistance. Well, E divided by R is how much current you will have. It'll take you back to that slide. Now, with the same thing goes with the pi, or the Watt's law. Okay, so there's Ohm's law and Watt's law. So the PIE, well, if you know how many watts it is and how many volts, so if you have 100 watts at 12 volts, you know how much current is flowing. And I think Leah is going to have some math to kind of demonstrate it. Take it away, Leah.
Yes. Alright, of course, as we see, power is energy and power is measured in watts. Power is equal to volts times amps. Hold on. Give me a second, Pete. Okay. Okay, I thought there was another one. Okay, my bad. Okay, power is equal to volts times amps. Multiply 12 volts by 2.5 amps and you end up with 30 watts. Of course, for me, it's like when you're doing the exam and you're trying to figure out the answer, usually what I do is I multiply or divide and figure out which one makes more sense. Of course, I weigh the answer too. Alright, here we go. This is what I was looking for. I got ahead of myself. Okay, since we are looking for E in this question, the voltage across the resistor. So you'll cover E with your finger. You now have I, which is going to be 0.5 amps times R, which is 2 ohms. Simply multiply these two values to obtain your answer of 1 volt. Sorry again. Okay, now we're here. This question is looking for voltage. So we know it's going to be a simple multiplication of 2 amperes through a 10 ohm resistor. And 20 volts is the correct answer. So you're going to multiply 10 times 2 and 20 volts. And you see the little finger diagram showing you how to figure out how to multiply it, get the answer. And that is a question on the exam. Okay, so be careful. They list current first, which would go in the bottom of your magic circle. And which, again, when you're taking the exam, and if you need sketch paper to figure, you can draw it out and make your pi or watt. And voltage at the top, divide to get the answer. So this one here, you're going to divide. So 90 divided by 3 is 30. So it's only going to be multiplication or division, but it depends on what you're trying to get. Okay. As a new technician class operator, you should be familiar with the identification of a schematic diagram illustrations, which there could be some schematic questions in the exam. Huh? Okay. You will learn on identifying individual symbols in the schematic for your exam, which LED is a really easy one to remember. And so, yeah, I think that's where you will want. Yeah, yeah, we have a video for that before we move into the next about power supplies, because he was trying to touch into that before we move on to the next chapter. Okay, all right, go ahead.
On the subject of power supplies, there are two main types of power supplies. Let's look at the schematic of a linear power supply. Here's the schematic for the typical linear power supply. The first, you will have a transformer. Now, in a linear power supply, the transformer is usually pretty big. Then you have the bridge rectifier. Now, the bridge rectifier turns AC into DC. Then you have a filter capacitor. The filter capacitor smooths out that voltage. Then there's the voltage regulator, and we could go into that more in depth later. And then you have an output capacitor. Again, this is to smooth out the voltage. All right, now, putting it all together, you have a linear power supply. Now, there is a drawback to the linear power supply, and that is size. Here, you can see that the typical linear power supply is going to be a little bit larger than most. Take a look at these meters on this power supply. Now, keep that in mind for when we look at the switching power supply and the size difference. Now let's take a look at the switching power supply schematic. As you can see that this is a little bit more complicated, and it's going to be beyond the scope of what we discuss, really, except for the fact that in a switching power supply, the transformers being used are a lot smaller. And the reason why is because what we're doing is we're using power MOSFETs to switch the power on and off super fast. And when I mean super fast, we're talking in the kilohertz range, not the hertz range like in a normal power supply, where the wall outlet is at 60 hertz. Well, inside of the switching power supply, we're talking about 40 kilohertz in switching speed. And again, the trade-off is size. Take a look at the meters in the front of this power supply. They're about the same size as the ones in the linear power supply. However, the whole casing is a lot smaller. That's because it does not have a big linear transformer in the back of it to step down the voltage. Well, thanks for watching.
All right. Thank you very much, Dawn, for working hard on that video for me as well. And as you can see, there was pictures of schematics in there. If any of you have done any kind of electrical work, then you know that you can read schematics. Or if you've built anything, you'll know about schematics. So, all right, we're going to move on to now picture this is what the next chapter is. All right, so your handheld transceiver can be dialed down to a minimum power output, dramatically conserving battery life. 500 milliwatts can be converted to watts by moving the decimal point 3 places to the left. So at 500 milliwatts output, you're transmitting at 0.5 watts power. So the least amount of wattage that you can run your power on, your radio on, is the best that you can, is better than having it at full power. Okay. It is easy to tell if you made, now if has anyone in the chat room done any soldering before? If you have done any soldering before, then you know how this works. If not, then we'll just teach you a little bit. It's easy to tell if you made a good solder connection if the solder looks shiny. It needs to be a shiny look. However, a cold, poorly soldered joint will look grainy and dull and won't hold as well. I had the opportunity to build a AM transceiver back in February with a group of lady hams down in Arlington, Texas, and this is the Murena AM receiver, and I'll turn on real fast. I already have it set on the station. and I really learned how to use schematics and soldering. This is really my first soldering project on my own. I've helped Donald a few times soldering, but this one was on my own, learning how to make sure that different components weren't touching each other, because if they touch each other then it won't work. Making sure that your just solder is nice and clean, and it was a fun build. So but anyways, I wanted to show that off real fast. Okay. Now, a good visual indicator on a handheld radio is the LED, which is a light emitting diode that is often used as a transmit receive, which yours on the top, isn't it? So I will have to speak first to make it come on. W3LEO testing. This is W3LEO again testing. So see the LED light on the top. My radio does not have the LED on the top of it. Some do, some don't. His is more of a digital. His is digital. Mine's not. But here is what an LED looks like that is not lit up. Here's a doll zoom in. Which a lot of you guys know what LEDs are, because they're also now in light bulbs, and they're all used all over the place. So you get it good for us. All right. And again, if you remember my radio, I have an LED here, which is one of the first things that you put in before you put it on. And one of your first things you do is you make sure that LED works. Then you know that this uses a 9-volt battery. All right, let's move on. All right, now is there any other questions? I know that one was kind of a little short-lived.
No questions.
Okay, now we're going to get into antennas. Now this one is extra short-lived. You will learn a little bit, but antennas are typically, you learn a lot more of it in the general class, and also hands-on. So then that way, this one here is just to get you through tests and learn the basics. Okay, but again, amateur radio is mostly hands-on, so that's one thing fun. All right, the dipole antenna, that's probably one of the most commonly used antennas that we have. So the dipole antenna is usually mounted parallel to the Earth's surface to transmit horizontal waves. Horizontal polarization is the best for weak signal, CW, and single sideband contacts. And you can see the picture down below. The dipole is a wire antenna, and then in the middle part is the insulator, and then down where it goes through the coax, which the coax comes down and then feeds into your line, which is your radio. That's how you get out in the air and talk to people. Now, to increase the dipole's antenna's resonant frequency, shorten it by twisting back a couple of inches of wire at each end, and it will work at a slightly higher frequency. Now, I don't know how to explain that part. So if anyone has any questions about that, I can turn it over to Donald if anyone wants a little bit more information. So like I said, there's more of it, more detail in the general class. Now, a beam antenna will concentrate signals into one direction. It has the reflectors, the boom, of course the coax, and it looks more like, I didn't even grab the one that we have, and I apologize. It's usually like a metal beam, and it has individual directors that go back, or elements. They're called elements. I knew that. I just read it off the screen. But it's also called a Yagi antenna. Here we go. Oh, okay, Donald's gonna go.
All right, so I want to touch upon what Leah said about the dipole antenna. So, and Leah, this may ring a bell with Leah here in a second. So I'm in the process of building an 80-meter antenna. It's made for 3.75 megahertz. I measured out the length of the wire to work on 3.75 megahertz. All right. Now, the other antenna I have is a lot shorter in length. So it's about 30 foot long total. The 80-meter antenna is about 120 feet long in total. So the longer the element of the antenna, the lower in frequency we go. So what it's saying there is if your antenna is like only 30 feet long, if you add a little bit more to it, you can go down in frequency. So that's what she was talking about there. Also on the beam antenna, there are three major parts to that antenna. You got the reflector element, the director elements, and then you got the driven element. And I'm going to toss it back to the picture here real quick so you can see it again. You'll notice that the director is in the direction, the directors direct the signal forward, and the reflector bounces the signal off of the driven element, from the driven element forward. And here's the picture again. If you notice there that the driven element is where you hook up the coax at, and from there the signal is actually driven off of that element and gets reflected off of the reflector, and the directors direct it into the pattern that you want the signal to go. All right, back to Leah.
Thank you. All right, here's a few examples of a Yagi, a quad, and dish antennas that are highly directional. They beam your signal into one specific direction. Those are also popular to use when you're trying to make contacts with satellite dishes, or satellites. When the space station comes over, you will use a directional antenna for that. If you're trying to find interference, you can use a directional antenna to help find interference if you're getting interference on your radios, and especially if you're having something inside your home that's creating it, you can use that as well. All right, was there any questions on this very short-lived spot of antennas? All right. Okay, now we're going to go in with feeding you some good coax. As you can see here, there's pictures of the different coax, which I have a few different connectors right here. We have, let's see, this one here is the PL. This one is one of the most common ones. The PL259. I know I've seen these. Of course, my husband used to work for the cable company, so I was always finding things like these in his pockets, and they were always being washed and dried. So, not this one, but it was more like these little guys here, and this is a barrel, SO239 barrel, which is that even on the picture? Okay, well these are but this one connects to this. Once I get, okay, never mind. But it's supposed to connect to it. I'm not going to fuss with it too much. And then this one here, refresh me on this one. I know we use this one. This is an SO239. This one is not, is this one? Yeah, this one is like similar to the no. This one connects to this. So they all tie into each other. Okay. Okay, now, when you get started as a new technician class operator, most of your external antenna work will most likely will include feed line called coax cable or coaxial cable. Like a garden hose, don't kink it, scrunch it, chop it, or squash it. It requires few installation considerations and can be run alongside your vehicle frame or along your home. Of course, if you have, it's a different type of coax, but if you have like coax from your cable TV, if you kink it the same rules apply. If you kink it, then you don't get the signal. Alright, now coax cable, it carries your transmitted RF signals from your radio and delivers it to your antenna. It also takes signals coming in from the antenna and delivers them to your radio, hopefully without leaks. Now, when you install your new antenna on your roof, double check the edge on the roof And make sure when you're installing it that you're also double checking that you have completely sealed that PL259 connector with a gooey substance called coax seal. I showed you what that was. This will also keep water out and prevent feed line losses. Feed line losses is going to be your most common problems versus water when you're coming to not losing signal. Now, moisture getting into coax is the #1 cause of lousy signal in the air. Coax. Since Radio Shack really isn't much around anymore, but don't buy the Radio Shack version if that makes sense. Quality coax is an outer jacket that will not break down in ultraviolet light. And it's meant to be outside. If your antenna match is perfect, you will have a low standing wave ratio, and then there will be an efficient transfer of power up coax for your antenna system with minimal signal losses. A handy piece of test equipment is the antenna analyzer. This allows you to work on the antenna safely on the roof, and then test it. Well, if you're on the roof, still be careful. And then test the resonant frequency without needing to climb down the ladder to transmit on your big ham rig. The little SWR analyzer hooks directly into the base of the antenna and allows you to do the test easily while on the roof. And I should have grabbed Donald's antenna analyzer to show you what one looks like, and I'm going to take it to Donald real quick.
So a good antenna analyzer is needed for doing a lot of HF work. Okay, as a technician class licensee, you're probably not going to need an antenna analyzer, and believe me, they can get expensive. I paid around $400, I think, for mine, and I know somebody else who paid over $1,000 for his. However, has a very good graphical user interface on it. Color screen. Mine does not have a color screen on it. It's just a LCD display. However, when you're working with HF, so when you get your general class license or even extra class license, that's where you're going to want to get an antenna analyzer. Now, you can always ask somebody if you could borrow theirs. I don't lend mine out, but if we're going to have a on-the-spot class or something like that, and you want to test out an antenna, you put it up in the air, I'll be glad to bring my antenna analyzer out. You don't know how many times I've been asked to loan out my antenna analyzer, so I just try to keep it with me because I'm always asked all the time, unfortunately. And I've been burned a couple times, but that's neither here or there. But I would be happy to help you test your own antenna with my antenna analyzer. And Leah's back, and she has something to show you.
I gotta get hooked back up again.
Oh, she's got to get her mic back on. She walked off, and I think she went to go grab the antenna analyzer. So, Leah, are you ready?
All right, I'm back.
You're going to be on the tight.
Okay. This is Donald's antenna analyzer. This is an AA520 by Rig Expert. He loves that brand because he uses it. Bought one for at work as well, because he does this at work as well. This right here is the coax. This is where you attach your antenna at. You know, the coax that comes from the antenna. You screw it onto here, and then you turn it on. Once I find the oh, you have to take it out of the packet. This is the protective bag. You take it out of the bag before you can turn it on, and it has all these different, got the ranges, frequencies, SWR, everything that, you know, this is Greek to me, but this is why it's important to have someone that knows what they're doing. All right, now again, we're talking about do that. Now, when trying to transmit, you notice your local repeater jumps up and down in signal strength. You probably have a loose connection up at the antenna or a loose coax cable feed line connector. Don't transmit. Safely get up on the roof and see what's loose. Ensure all connections are tight. That is your biggest thing, is make sure everything is tight. And I didn't bring that one in here either. It is a good idea to invest in a dummy load. We do have one of those as well, but that's okay. It's like what's in the picture. It is a valuable piece of test equipment. Test your new radios with a dummy load, which prevents the signal from being sent out in the airwaves. And now we're going to go back to Donald.
All right, so using a dummy load is critical when testing. You can also make your own dummy load. They got like a dummy load that you put in a paint can. It's a kit that you can build. I also have that 300 watt dummy load. Now it's 300 watts for like 1 minute. As the time goes on, if you're going to put 300 watts into it, it gets hot and starts to degrade in time. So you can only handle 300 watts for so long. Now I do have a 150 watt dummy load available to me, and even 1,000 watt dummy load that I can use as well. I've never used them, but I've never really found the need. Also, another dummy load can be your standard incandescent light bulb. Yes, you can use a light bulb as a dummy load. All right, back to you, Leah, on the wide.
All right, thank you very much. All right, obviously this is common sense. Remember, green is for ground. The three ground plugs should always have the ground connector in place to provide safety, so never cut it off. There's a reason why it's there, which I would think none of you guys would do that. All right, never work around anything electrical on your bare feet. Now this is where safety, even though safety is first, this is the last chapter in the book. So it's kind of ironic, but we're going to go over some safety things. Again, never work around anything electrical on your bare feet. Put your shoes on. Never do laundry with your bare feet. Sorry, I've done that. But if a current is allowed to enter your finger and pass through your body out to the ground from your bare, sweaty feet, you will be toasted for sure. Current flowing through your body is a lethal health hazard. And that is a question on the exam. Now, high voltage is not something you want to work on alone. To be really safe, unplug the equipment in question. Fully discharge any capacitors with a shortening stick. Attach your voltmeter probes to test the points in question with insulated alligator clips, and then reapply the power from a safe distance. Now, overcharging any type of battery, including your little handheld battery, could cause it to heat up and give off dangerous gas or even explode. So be very cautious even with your new handheld battery, and charge it only on the supplied charger. So don't try and shove it into one that doesn't belong with it, because that will cause problems as well. Now, storing batteries. Storage batteries can supply immense amounts of current and act like an arc welder if their terminals are shorted out. Be careful when replacing automotive batteries, because we do tend to use automotive batteries for our way of, because they've produced enough power for us to do our radios. As well as dropping a wrench across the battery terminals can cause immediate and extensive hissing and fizzing. Now remember, that extensive hissing and fizzing, if that's the one question you get right, that is in the exam. All right, many ham operators who work in emergency communications have a spare 12-volt battery outside their ham shack. They can tie into it for emergency power if necessary. The reason we leave the 12-volt battery outside is it contains a dangerous acid and could spill. It has plenty of power that could cause a fire, and if improperly charged can give off an explosive gas. So keep those 12-volt batteries safely outside. Anytime you're working on an antenna system, look at all over the place for any overhead electrical wires and steer clear of those fatal attraction conductors. Normally those wires were on the top of a power pole or uninsulated bare wire, and a brush with those two top wires could be your last day in ham radio. So watch out for overhead electrical wires. Now, if you're going to climb on your tower, if you happen to have a tower, we have a 40-foot tower in our backyard, even though people somehow manage to not see it, but we do have one back there. Double check that your fall prevention safety harness is OSHA approved and that all connections are cinched up before climbing the tower. Never climb alone. Wear safety goggles and a hard hat, and always observe climbing safety every step of the way, up and down. Now, the next time that you're at an antenna raising party, or you have an antenna raising party, you'll probably see a gin pole. This is a pole with a pulley that straps onto the tip top of the highest tower section, allowing you to lift more tower sections up as well as the final antenna assembly. It is a lifting device, and that is also on the exam. Here's a picture of our backyard. It shows this, our little 40-foot tower antenna. Each tower, well, I think 8 feet is actually it's a 48-foot tower, 8 feet is underground. Each tower leg, usually 3, gets its own 8-foot ground rod. Each rod is bonded to each other, forming a triangle, and then bonded to the tower for lightning protection. But as we had some storms that rolled through, we went ahead and unhooked the antenna from the radio to make sure we didn't have any issues from that. So that's another good safety thing to remember. But as you can see, we have a dipole antenna in the back. It's actually it goes strung across. It goes to the tree in the front of the house and to a tree in the backyard. And then we have a couple, what are those antennas called? Vertical antennas. My goodness, I'm sorry. So we can do 20 meters, 40 meters, and I think, and then of course we're working on an 8 meters and 2 meter centimeter, which is our local repeater. That's and what? 2.4 and 2.48, which I don't ever get. I usually just do 20 meters and 40 meters because it's easy for me, and I like doing that. Okay. When you're really gung-ho with your ham radio hobby, you'll want to install a ham radio tower. So again, watch out for the high voltage electrical wires. And when I did that, okay, usually, again, some stuff will repeat itself in a sense. Usually the top 2 wires are not protected with outside insulation. Down at the base of the tower, make sure that your grounding wires are as short as possible and they directly go into the earth. Now, the best method of grounding your equipment is with a flat copper foil ribbon. It's usually about yay wide. We use braided. Yeah, we have about 1 inch wide. The flat strap offers the best surface area to bleed off static and to minimize ground currents that could cause interference. The strap usually comes in 3-inch widths, and you can fold it once or twice in order to snake it down to a healthy ground rod. Now remember that your operation on different radio bands changes the frequency of your RF emissions. At certain wavelengths, around 6 meters, the human body absorbs more RF energy. On lower frequency worldwide wavelengths, the body absorbs less RF frequency, or RF energy. And that's also a question. In order to prevent exposure to RF radiation in excess of the FCC specified limits, you may need to relocate your antennas. So that is very important too. You don't want to give yourself radiation burns. The transmission of radio frequency energy from your antenna is considered non-ionizing. You can read the word. I don't know why I'm having a hard time saying that word. Radiation. This is altogether different from X-ray, gamma ray, and ultraviolet radiation. Radio frequency emissions from your new ham radio station will vary in duty cycle, depending on what type of emissions you are using. On FM, every time you key your microphone, your transmitting is working at full tilt. Now, unless you're transmitting ultraviolet, you probably aren't going to be significantly ionizing anything at amateur radio power levels. As an amateur operating under legal power limits, your chances of causing any ionizing radiation are essentially 0. Now, when you pass your technician license exam, you are allowed to operate up to 1,500 watts output of RF energy. So make sure that no one can touch the transmitting antenna with a major amount of power, because if you accidentally touch it, the antenna will cause someone to be burned or injured. And it'll go to Donald.
So I can tell you this from experience. At 600 watts, I touched an antenna that was actually causing coronal discharge at the tip of it. And if you haven't seen coronal discharge, that is super neat. However, the burn from it is unlike any other burn that I ever had. It it was like internal, and it was weird. So don't touch a don't make it to where you can't touch an antenna that's being transmitted on, especially at high rates of power. Back to you, Leah, on the type.
And even if you have your antenna on your vehicle, same way, because because your car radiates, it holds that power, and if you touch it then too, you can get zapped as well. So just keep that in mind. Antenna transmitting bad. All right. Are there any questions that you guys would like to ask in the chat? Well, I have one quick question before I give you guys homework. Why are you wanting to get your technician license? I just want, comment in the chat, and I'm just curious, what made you decide to get your technician license? I got my technician license. Initially, Don got his license because he wanted learning about other ways of communications outside of cell phones. Obviously, we live in Oklahoma. There are many opportunities when we don't have cell phone coverage because, well, we get tornadoes a lot. And so he got his license before I did. And then we had made some new friends. And in turn, myself and 2 others got our license. And it's basically like, if you get your license, you'll get her license, that kind of deal. So I ended up getting my license this month. I can't remember the exact date. But this month in 2011, so I have had my license 9 years, and so I got my technician, then I studied for my general. Took me a little while, and then I finally got my extra class about 2 years ago. And even if extra class isn't fully what you're wanting to go with, that's fine. Don't stay at the technician level. Upgrade to general, because then you can do more of the HF frequencies, and it gives you more opportunities to be part of that vast world of VX, where you're able to contact someone out of country versus just out of state. So, but it just gives you, but you have a lot more opportunities. So, all right, guys, I have some homework for you. Those that are coming to test this next Saturday. If I've already talked to you by email, you are on my list. If I have not talked to you by email and you have just joined with us, please email me to get on the list. It's going to be Whiskey 3 Lima Echo Oscar at Whiskey 5 Mike Whiskey Charlie.org. We are looking at a 2-hour session. We may have to expand it because we have about 16, or almost to 20 people signed up to take their test, which I'm really excited for. But again, keep this in mind. Since we're still having to do the social distancing part of it, it might take us a little longer because we have to spread out and take turns. So be prepared for that, okay? Again, this is homework required. If you don't want to give me your social security number, which I'm not keeping it, it's going to go to the ARL, which in turn goes to the FCC. But the FCC needs your social security number. Oh, I have a question?
Robert Ray wants to participate in soda, which is Summit on the Wheel.
Oh, how fun. Okay. So what is it? Which summit are you going to activate? Robert. I know he signed up also to take the class, to take the exam. My fun stuff, I like doing special events. There's some people who really love to do contesting, really get out there and you're really pushing it to get those one specific or one country or state or whatever. I like special events. On Saturday, I got on because it was Worldwide Amateur Radio Day. And of course, most of them were doing a lot of QSO parties, which is when states are going around trying to get other states and they're having a party. I didn't participate in that, but I did make contact out of Tucson, Arizona for the 50th anniversary of the safe return of the Apollo 13. So I will get a cool certificate with that once they complete that. So, all right. Now, again, if you don't want to give us their social security number, you can go to this website down here at the below that's on the link or on the slide here, to the fcc.gov. I don't know. But that's where you can go in. You can if for some reason this doesn't work, for whatever reason, just do the search for the FCC ULS registration, and then it'll get you to that link, and you'll register, and you'll assign you an FRN number. If you don't get to do it, that's okay. You will still be issued an FRN number later on. Okay. Now, this is what it looks like. This is what you're going to look for when you are going to the website. You'll be to the the FCC website. You will go to register, where it says register and receive your FRN number. Once you click on that, they'll ask you if you're a business or an individual. Obviously, you're an individual, and that your address is within the United States or its territories. Obviously, the basic information, it needs to know where you live and your name. Just fill them out like any other thing. And make sure you have your current address, because that is very, very important. And again, here, you still will put in your Social Security number, but that will be for them to have. And of course, it won't be shown on there. And then this register number, FRN, the 0024, etc., that's the number or one like it that you will be assigned. That's what we will put in the paperwork, which we will help guide in the paperwork when we get to that point. And before we say goodbye, when we do the testing session, we ask for all the safety things. Go ahead, and if you provide your own pencils, calculators, I would bring a clipboard, because we're going to be at a park in a pavilion, and sometimes the tables are kind of rough. And if it gets a little windy, you don't have to worry about your test blowing away. I can have scratch paper and things like that. So just bring that with you. And of course, it's $15 for the test. If you have any other questions, you can email me. So I want to thank you guys for attending our little Crash Course 2020 Technician class. But if you would, if you're on Facebook, like our Facebook page with facebook.com/W5MWC. We do post there often. For events and special meetings that we'll be hosting. Also visit our website. It's still under construction, so bear with us, but you can still get information on there, and you can sign up for a monthly newsletter, which comes out right before the first of the month, which will be www.w5mwc.org, which W5MWC is our club call sign. And I think we're it. Yep, Nancy right there. I gave you my information. I added that in last. So again, if you have emailed me and I have spoken to you about the testing session, you're on my list. You're good to go. So you don't have to worry about emailing me back. So I think this is it. Thank you again, guys, for joining us tonight and taking time out of your night to learn this. And I hope that we've been very helpful for you. And again, if you have any questions later on, feel free to email. Go on our Facebook page, things like that. So, again, thank you so much for joining us tonight. And we're going to say 73. This is best regards. This is W3LEO saying good night.